Hello again. I'm going to talk to you about a big math section about a way of counting particles called the mole. And we're going to use this a lot throughout this whole class, so this is another big concept we need to figure out how to use. So if you went to the beach and wanted to measure how many grains of sand you had, it would take a long time to count each grain. It's a lot easier to weigh things. So find the mass of the sand that you have. And then if you knew how much a grain of sand weighed and you know how much total mass you have, it'd be a lot easier to figure out the grains. We're going to do the same thing. We're going to use the number of particles, and we're going to use a word called mole to designate that. And we're going to compare moles and mass. So grams to moles, we're going to look at that. So the amount of grams in 1 mole is called a molar mass. So we're going to use that fact. And so this section's a lot of math. So there's 3 ways of measuring the amount of something. We can count, we can take the mass of it on the balance, or we can measure the volume. So those are the things we do in chemistry. So we could figure out what is the mass of 90 apples if we know 1 dozen has a mass of 2 grams. So we can use all that information to figure that out. So we'll do the same thing with atoms and molecules. So if we had this problem, we could start with number of apples, go to dozens of apples, and then figure out the mass of apples. And so here's all the conversion factors to do that. If we took the 90 apples, we knew that there's 1 dozen has 12 apples, so apples cancels out. Dozen is 2 kilograms, then we can cancel out the dozen, and we'd come up with kilograms for those 90 apples. So we're going to use unit analysis again. We talked about it a little bit before. We're going to use that a lot in this section. So this is a math-intense section. It's called stoichiometry, so we're going to use this a lot. So then we just make sure we got the right answer. So they always have these evaluate sections. So let's relate that to elements. Elements can be measured in something called a mole. And so this chemist a long time ago named Avogadro, sounds like avocado, but it's Avogadro, figured out that if you had a certain number of atoms, it will be a particular mass for each element. So we're going to use that information from Avogadro. So this is the number that he came up with. So if you look at this many particles, which is a lot of particles, you can figure out the mass of 1 mole. So we're going to call this thing a mole. So you know dozen is 12, so mole is this. So that's all it is. It looks like a weird number, and the name is weird, so it kind of bothers people the first time they deal with it, but don't let it bother you. We need to use it a lot, so please really get used to this. We're going to use moles. You'll use this for the rest of the time you're in chemistry. So instead of dozens, we're going to talk about moles in this class. So the representative particle could be anything. It could be an atom, it could be a molecule, or it could be an ionic formula unit. So we can talk about anything. Like we can talk about dozens as for donuts, or for apples, or for pies. We can have a dozen pies. Same thing with a mole. We can have a mole of atoms, we can have a mole of molecules, or a mole of formula units, which remember means ionic compounds. So 1 mole is this is the definition. We have to have this. You have to have this in your mind. You have to memorize this. We're going to use this number a ton. We're going to use this a lot. Just like a dozen is 12, well, 1 mole is this number. It's just a number, so don't let it get you freaked out. It's just this number with tons of zeros after it. So 23 places of zeros after there. So it's a huge, huge number. Because atoms are so small, we have to use a huge number to have something that makes sense. So we want something that we can see in our hands. 1 mole will fit in your hand or a couple of your hands. And that is 1 mole. So that's why we designate this huge number as a mole, because we want to be able to measure something that makes sense in the lab on a balance. So that's a mole. And so 1 mole of this many particles is that many pieces, that many things. Okay? So we have to know this. This is an important thing to memorize. And you can have anything. Anything can be, you can have a mole of anything. You can have a mole of a molecule, this many sucrose, that's sugar molecules. You can have a mole of nitrogen atoms. You can have any one of these things as moles because it's just a counting unit. So this is like a basic kind of question we're going to be asking you a bunch in chemistry. How many moles of magnesium if you have that many atoms? So we're going to use our conversion factor, that 1 mole of magnesium is that many particles. And we're going to take the given and we're going to make a conversion factor setup for it. So we're going to start with this many atoms as the given in the problem. So how many sig figs is that, would you say? This is 3 sig figs, so our answer has to have three numbers in sig figs in the answer. So if I start with this many atoms, I have to put atoms on the bottom of the next step for these two to cancel out. So this, the math, you're going to do this times 1 divided by this in your calculator. So try that. Make sure that you can come up with the right answer, and you can use this EE key in your calculator. Remember the exponent key. We need to be able to use that. So try this question, pause the video, try it out, see if you can get the answer on your calculator. It's really important that you can use your calculator correctly and get the right answer. So your answer should be this. In your calculator you might see this. You might see just this number in your display of your calculator, and then you might see an EE key, and then you might see -1. Some calculators just show this -1 in the right corner. They have this number, and then they have that little -1 sign in the corner. So see how your calculator works. You probably should go on YouTube and find videos on how to do exponential stuff in your model of calculator. There's got to be a YouTube out there for you to try out. So please look at that and see if you get this answer. So again, I said there's 3 sig figs here because we're looking at this number, not how many zeros there are. We're looking at this right here. 3 sig figs. So your answer has to have 3 sig figs. The 0 is a significant figure. Okay. So make sure you can do this as a basic problem, and we have to do a ton of these in chemistry all the time. So this is important that you know how to do this. This is essential. This is an essential skill for you. Okay. So we're going to go back and forth between moles and particles, and later we're going to go from moles to grams to particles. So we're going to add one more step. So if we had 2.12 moles of propane, now we can go back to atoms. We can go the other direction. So this is the given, 3 sig figs, that many moles, how many particles? So we're going to use this and this fact to figure it out. We're going to start with the moles that they gave us. We're going to go to molecules. We're going to go to atoms. So we're going to have an extra step in here because in every one molecule of this guy, there's 3 carbons, 8 hydrogens. So total, there's 11 atoms. So this is like a next step on top of grams to mole. Moles to particles, particles to moles. We're going to do one more step. So we started off with 2.12 moles of this guy. We got to get rid of moles, so it's going to go down below. We're going to change to molecules. Then they are not done yet. They want to know how many atoms do we have. So in one molecule of this, there's 11 atoms. So math-wise, you're going to take this in your calculator, multiply by that, divide by 1, which will be the same thing. You should get this in your display of your calculator, and then we have to think about sig figs. So try that in your calculator, pause the video, check it out, see if you can do it. Since I have 3 sig figs in the given of the problem, I have to round to 3 sig figs here. So I start on the left, 1, 2, 3. I look at the number after it. Is it 5 or bigger? No. So I'm just going to get rid of these 2 numbers right there, and it'll be 1.40 times 10 to the 25 is my answer. So I went from moles to molecules to atoms. So you can do lots and lots of steps in a conversion to get to where you need to go. So try that. This is a really important problem that you try out on your own so you can see how your calculator works and that you can get the right answer. This is a basic problem you see on quizzes and on the tests and final. So let's talk about how we could get to grams. We talked about the beginning, weighing a whole bunch of sand to see how many particles you have. This is used a lot. We do this in the lab all the time. So this is a basic skill we need. So like I said, we're going to use that thing called the molar mass. Don't make it a bigger thing than it is in your mind. It's just how many grams are for 1 mole. So it's like you took a dozen eggs and you weighed them. So 12 eggs, how much does 12 eggs weigh? That's like a molar mass. It's not that big a deal, but this word, for some reason, bothers people, so don't let it bother you. Just how many, mass is always grams in a mole. Not bad. So this is why we decided to use a mole, because look, you can see these in the lab. You can see this with your hand. You can have a handful of carbon, because carbon looks like this. You can put that in your hand, and that's a mole. Sulfur is bigger because it weighs a different amount of carbon, okay? And it has a different packing structure. Mercury is really dense, so it's a smaller amount, but you can still see it, and it's like a handful. So all these are basically a handful or 2 handfuls full of the element, and so that's a mole. So I just wanted you to see what they look like in real life. 1 mole looks like this for each of these types of atoms. It's a really useful picture because we're going to be looking at fractions of moles and things like that. I need you to know what 1 mole looks like. So, what else do I want to show you? So we use the carbon atom for the basics for moles, and we decided that 1 carbon is 12 AMU. And then remember, all these little numbers are on the periodic table on the bottom. I'm going to jump to this. This is not so important. We're going to move on. But remember, the thing to remember on that last slide is that each atom, if you look at 1 atom, it's measured on the bottom of the periodic table square at the bottom. It has just has a number, and that number means either for 1 atom it's AMU units, or for 1 mole it's in grams. So that number, basic number that's mass on the bottom of the little square, is for 1 atom, and it's also for 1 mole. So that's what that last slide was trying to show you, but it's not a very good slide. So how do we do the mass of a mole? To calculate molar mass, you find the grams of each element in that compound, and then you add them up. So finding a molar mass is 1 step. So for example, I want to find out the molar mass of SO3. Okay, so there's 1 S and 3 O's. So I look at the periodic table. There's 1 S, 3 O's. I look at the table, and it says that S is 32 grams. Or 32 AMU for 1 atom. For each oxygen, it's 16. I have 3 of them, so then I add them together. So if I had 1 molecule of this, just 1 all by itself, it would be 80.1 AMU. But what if I had a whole handful, the mole section, the mole amount? It would be 80.1 grams. Okay? So 1 mole of SO3 has a mass of 80.1 grams, but 1 molecule has a mass of 80.1 AMU. So we have to know the difference between those two. So this is a unit for 1 individual atom or molecule. This is the unit for 1 mole of the compound. So 80.1 grams per 1 mole. Right there. So you have to get used to doing this simple math for molar mass for a molecule. So I need you guys to know how to do that. So here's some different masses. Sugar is a huge molecule, glucose, blood sugar, so it weighs a lot, 180 grams. Mothballs weigh 147 for a mole, and water weighs 18 grams for 1 mole. So we just add up all the masses of each individual element, times 6, times 4, times 2, add them up, and we get that. So each molecule has a different mass and different molar mass. So what if we were going to look at how H2O2 decomposes when we launch a rocket? So what's the molar mass of 2 H's and 2 O's? So you can look at the periodic table. Each H is 1 gram. We have 2 of them. We have 2 oxygens, and so we have to multiply that by 2, and then we add them together. So 2 times that, 2 times that. For every 1 gram, for 1 gram of hydrogen, it weighs 1 gram, but we have 2 in this molecule. We have 16 grams for each oxygen, but we have 2 in this molecule. Then we figure that out, add them together. So this is a basic skill we need to know in this class, molar mass, how to figure that out for a molecule, a mole of that molecule. So you could try that one, and then let's try a quiz. So what are 3 common ways of measuring the amount of something? 3 ways. Count, mass, and volume. So we do all these things in the chemistry lab. So what do you think about this? So what do you call this thing right here? H2 gas. Molecule. There you go. Last one. The AMU for 1 fluorine is 19. So what would be the units for 1 mole? So this is a good question. So I need you to know this one. So for 1 mole, it would be 19 grams. Remember, this is just for 1 atom, and this is or molecule, and this is for 1 mole. Okay? Alright, I hope you learned a lot. This is a really important section, so if you had trouble with this, please go back through and try it and then read the book on it as well. Because this is like a basic skill we have to have. And I'll help you with this. Alright, have a great day. Talk to you soon. Bye-bye.